Today we're going to talk about angles formed when chords intersect. That will be secant and tangent lines. We'll be intersecting inside of the circle, outside of the circle, and all kinds of stuff. So what we have here is a tangent line intersecting a secant line. We have a little formula sheet for this, but what we learn and what we know is whatever this angle is, the arc on the other side is half of that. So when we're calculating this value, that's what we need to know. This would be this arc that's right here is going to be half of the arc mark. So let's see what we are given in this particular question. We have an angle from arc from A to Z to L. So that's a really big arc we've got going here. That's a major arc. But this major arc has a measurement of 258 degrees. And they're asking me for what the degree measurement of angle L to A to M is. So this is that formula we were talking about. What we know is this, that the angle is equal to half of the arc. So the angle measurement LAM is equal to half of the arc, which in this case our arc is 258. So we're going to take half of 258. And we learned that angle LAM, half of 258, is 129 degrees. So on the next line, we are talking about two secant lines that intersect, and we're given the arc marks. We're given the arc mark of KR, which has a value of 124. And we're also given the arc of TH, which has a measure of 90 degrees. So when we're doing this one and we're looking for the angle, now it doesn't really matter which of these two angles it is, this side or that, because those are vertical angles. But when we're calculating this amount, the angle is basically going to be the average of those two amounts. So when we're talking about angle TIH, it is equal to the sum of the other two angles. Well, that would be 90 plus 124 divided by 2. Like I said, it's the average of those two angles. So angle TIH is equal to, this would be 214 divided by 2. So the angle THIH, is equal to 107 degrees. And that makes sense. That's an acute angle or obtuse angle there. So we can see that's what we have. We're going to move pretty quickly, so hopefully you guys are right on board as we go through these. We've got about 8 examples, but we're going to just move right on through. So as we look at this example, what we have is two secant lines that are intersecting on the outside of the circle. So again, always look back at your formula sheet. What we learn is this angle M, and we can just call it angle M because it's the only one, is equal to the larger arc minus the smaller arc, all divided by 2. So we've got to be very careful on this because that looks a lot like the last formula, in which case we added the 2 and then divided by 2. But at this one, we're going to take the larger arc minus the smaller arc and then divide that value by 2. So our information tells us that arc NEN has a measure of 94 degrees. That is the larger of the two arcs. And TH has a measure of 30 degrees. So just like the formula says, what we need to do is take the larger of the two arcs, which is 94, minus the smaller of the two arcs, which is 30, and then we're going to divide by 2. 94 minus 30 is 64, divided by 2. So the measure of angle M is equal to 32 degrees. It's very important we get familiar with our formulas, but it's also important that you pay attention to what we're being given. So in this one, we have the same figure as last time, but in this case, we're given that angle on the outside of the figure to be 56 degrees, and we're told that BZ, this angle right here, the smaller of the two angles, is 60 degrees. We still use the same formula. Remember, the formula is the outside angle equals the larger minus the smaller divided by 2. It's just a matter of what we have here is very different. We have the measure of the angle, that's 56. We also have the measure of the small angle, which we established as 60, but we do not know the measure of the large angle. We'll just leave it as L for right now. We can call it XL, we can call it whatever we want to call it. So we get down to this measurement. We set up our formula, and once we've set up our formula, we just simply solve from here. So I want to get rid of the denominator of 2, so I'm going to multiply both sides by 2. So this is 112 equals L minus, the large side minus 60. So we have to add 60 to both sides, and what we learn is the large side would be equal to 172 degrees. Now the large side, if we were asked to name this, HP, arc HP has a measure of 172. So on this particular one, again, we see we have that exterior angle, JM, which is 37 degrees. And we have LQ, which is the larger arc, which is 108 degrees. And then we're missing the smaller one on the inside, which is RT. So we just set up the formula the same way we know. We know that that exterior angle is equal to the large angle, 108, minus the small angle, which we don't know yet, divided by 2. And essentially we're dealing with the same process. We're going to multiply both sides by 2, which would kill our denominator. And then 37 times 4 is going to be 74, excuse me. I'm going to move the 108 to the other side. I know that gives me a negative number, and we obviously can't have a negative degree here, but the side is negative, or the small side is also negative here. So when we subtract this, this is negative 34 degrees, which means the small arc, is going to be 34 degrees. And the small arc, of course, is RT. So arc RT is equal to 34 degrees. Just 2 more examples here. So in this one, we're given the arc of NTF, that major arc that we have right there, T passing by N, going to F, equals 278 degrees. We've got to pay attention here because they're asking me, well, what is the measure of angle F to T to H. Well, in this case, we can do one of two things. It really doesn't matter which process you use. You could find this angle right here and then subtract it from 180 because it's supplementary. Or you could do what I'm choosing to do here, which is to say this. If I knew this arc mark, I could just use the formula there. But I do know that arc mark because I know a full rotation is 360 degrees. And I know that 278 degrees are on the other side, which means there are 82 degrees left. So this arc mark TF is 82 degrees. And this angle that is created, in this case, that's the measure of angle FTH, the one we're looking for, is half of that amount. So I could multiply this times 2. It would take 2 of these to make one of those. But instead of doing that, what I'm going to do is I'm going to go to the right side and take half of that angle. Now, if you did it the other way, that's perfectly fine. Nothing says you have to do it one way or the other. Just make sure that you're finding the appropriate parts. And then use your common sense on this. This is clearly an acute angle. So if I have an obtuse angle measurement, we should immediately have a red flag going up. And our last little example here. Again, it's kind of the similar thing that we were dealing with. We just have different parts here. We're going to use the same formula. So du, arc du, let's highlight that. Du has a measurement of 165 degrees. And it tells us that angle DTU, has a measure of 120 degrees. And they're asking us what is the arc measurement of HW. So we still use the same formula. And remember, the formula essentially is that central angle. It's not a central angle because it's not on the center, but that middle angle is equal to the average of the other two. That would be 165 plus HW, let's just call it X for now, divided by 2. Once we set up our equation, we just work our way right through. So this is going to be 240 degrees equals 165 plus X. We are then going to subtract 165. And we learn that that arc mark is equal to 75 degrees. So these are our secant lines, and we're learning about angles. Tomorrow we'll start taking a look at the segments and how they relate to one another. You guys have a Delta Math. You should have been working on that already. Good luck.